Okay, this is 6.6, solving absolute value inequalities. Now, this is the same thing we did before, where we have the absolute value of a number, or absolute value problems, but now we're comparing them. Letter A is talking about the absolute value of x is less than 9. Well, think about all of the numbers, or I'm sorry, less than or equal to 9. Think about all the numbers that have an absolute value that would be less than 9. That would be like 9, 8, 7, all the things in between, 6, 5, 4. But guess what else has absolute values that are less than 9? Negative 9, negative 8, negative 7, because all of these absolute values would become positive absolute values, and so on and so forth. And here's kind of our range. We would go from positive 9 to negative 9. That means x is going to be less than or equal to 9, but it's going to be greater than or equal to negative 9. Do you see that we have just created an and compound inequality? Hip hip hooray! And we put this on one graph. That means we have a closed dot on negative 9, a closed dot on positive 9, and it'd be all of the numbers in between. All the numbers in between. So if we chose negative 3, the absolute value of negative 3 needs to be less than or equal to 9, and that absolute value is less than or equal to 9. So if the absolute value is greater than 1/4, that means we need 1/4 and bigger than 1/4, but the absolute value could also be negative 1/4. But then I need the numbers to get bigger, so that means my absolute value needs to be less than negative 1/4. Do you see that the signs switch every time? Even on our last example, we had a less than sign and a greater than sign around the x. Your signs flip because to represent the positives and the negatives. So the absolute value has to be greater than 1/4. Well, then we need the numbers bigger than 1/4. But in the land of negatives, the bigger the number gets, the smaller the value. So we actually need to go less than x. This is an or compound inequality, where positive 1/4 would be here, and I need to be greater than that. Negative 1/4 would be here, and I need to be smaller than that. So like negative 1 needs to have an absolute value bigger than 1/4, and it does. Positive 1 should have an absolute value bigger than 1/4, and it does, 1/4. So every time we take it and flip the sign. Kind of a quick reminder, if you have a less than sign, it is an and connected inequality. If it is a greater than sign, it is an or compound inequality. One way to remember that, more is or. So if it's greater than more is an or split apart compound inequality. So this one is the absolute value of 2x minus 7 is less than. Less than is an and. So I can do the absolute value. Oh, sorry. That is not it. I have my absolute value problem by itself. So now I'm ready to gut it. I have 2x minus 7, and I have that less than 9. And because it's an and, I connect it and make it greater than negative 9. And is connected because it's a less than. Less than makes it an and. Do you notice that my inequality symbols are gone? They are no longer there. And then I add 7 to both sides. Divide both sides by 2. And there I have my compound inequality. Graph it, negative 1 to 8. Shade, and they're kind of in the middle. And then you choose a number to check. Now, because I have one shading, I have one check. One shading, one check. One shading, one check. So I'm going to choose 2. Plug it into the original. 2 times 2 minus 7, and all of that, the absolute value, has to be less than 9. Well, that's 4. Minus 7 is negative 3. The absolute value is less than 9. Here, when you solve this, you got to get the absolute value problem by itself, plus 4 on both sides. The absolute value of x plus 8 is greater than or equal to 6. Greater than or equal to is an or, more is or, so split this up. I'm ready to take my absolute value problem and gut it. X plus 8 has to be greater than or equal to 6, or x plus 8 can be less than or equal to negative 6. More is or and split apart. So that means x is greater than or equal to 2, or x is less than or equal to negative 14. Your ors should be apart. Your graph should be apart. Greater than or equal to negative 2, less than or equal to negative 14. 2 shadings means 2 checks. So the absolute value of, let's do negative 15 plus 8, and then minus 4 has to be greater than or equal to 2. Negative 7, and that would be 7 minus 4, and that gives me 3, which is greater than 2. Here I've got, what, negative 1, and then minus 4, that is the absolute value of 7. 4 greater than or equal to 2, and that's 7 minus 4. So 3 is greater than or equal to 2. Nicely done. This does work out.